Hello all, my name is Tibanjan Chaudhary and welcome to my YouTube channel. In this particular video, we are going to continue further with set theory. Now, in this particular video, we are going to have an understanding of what are Venn diagrams and what are the various set operations. Okay. Now, before starting this video, I'm going to tell you that if you haven't visited my last videos, right, last two videos in set theory, I would ask you to please first visit those videos and have an understanding of what is set theory and what are the various points which we have discussed in set theory, because it will be easier for you to understand this particular video than after, right? The link of those two videos are provided in the description section below. Now let us start with the Venn diagrams. Okay, so first let us understand what do you mean by Venn diagrams. Okay, so as you can understand that these are nothing but some kinds of diagrams, right? So with the help of which Venn diagrams are nothing but some kinds of diagrams with the help of which we understand, or we try to pictorially understand what a set is and what are the various relationships between various sets. Okay, so what do you mean by Venn diagram? Okay, so it basically represents, okay, relations between sets in a diagrammatic way. Okay, so let me just draw a first Venn diagram and let me explain you what are the various components of a Venn diagram are, right? Okay, so this is nothing but a Venn diagram. Okay, so you can see we have a rectangular, diagram, a rectangle inside which we have a U. Okay, so U is nothing but a universal set. Okay, so U is basically called as a universal set, and A is a set. Okay, any set. So what do you mean by a universal set? So think of it as a universe. Okay, so in our universe we have got solar system, we have got various galaxies, we have got various planets, right? But those things, right, for example the planet Earth, this belongs to a universe, right? This belongs to the universe. So you can say that the planet Earth is nothing a part of the universe, right? Similarly, a universal set is a set which consists of all the sets. Okay, any set, suppose A I have written, I can write out some set as B here also. Any set, right, is belong or is basically a subset of this universal set. So you can write A is a subset of U. So we have discussed about what are subsets, right, in our last video. So please do watch that particular video and you will be able to understand what is a subset. So A is a subset of U. That means A is nothing but a part of U, right? So I hope you are able to understand the Venn diagram structure, right? Now let us take some examples in order to understand this concept in a much better way. Okay, so suppose we all have learned about Z and W, right, in our previous lecture. So what are Z? Z's are nothing but integers, right? So can you tell me the set of integers? It starts from minus infinity, okay, it goes 3, minus 2, okay, minus 1, then 0, then again 1, again 2, okay, in this way it's going to go till plus infinity, right? Now what W consists of? W consists of 0, 1, 2, 3 and till infinity. So we can say that W, right, W is a subset of Z, right? Why? Because W consists of all these numbers, right, starting from 0 till plus infinity, and Z already consists of these numbers, right, starting from 0 till plus infinity. It consists of these numbers plus some other numbers as well, the negative numbers. So W is a subset of Z. Now how do we represent it in in form of a Venn diagram. Okay, so if I draw a Venn diagram like this, okay, this is the universal set. Okay, Z is nothing but the superset and W is nothing but the subset, right? So Z should be here, right? And W, since it's a subset, so it will reside inside Z, right? It will be inside Z. So we'll be drawing it in this way. So first circle will denote, the outer circle is going to denote the superset, that is Z, and the inner circle is going to denote the subset, that is nothing but W. Okay, so I hope you are able to understand this example. Let me give you one more example. Okay, so so if I write, say we have a set A, and this set consists of, A, B, C, all the alphabets, okay, up till Z, and I have one more set, that is nothing but B, which consists of all the vowels, that is A, E, I, O and U. So clearly we can say that B is nothing but a subset of A and A is nothing but a superset of B. If I draw the Venn diagram, this is U. So the superset will always be the outer circle, right? So A is the outer circle and B, since all the elements inside B reside inside A, so it will be the inner circle, right? Okay. Now let's do one more example. Okay, now let me give you an example with the help of set builder form. So if I write it in this way, say X is a set, okay, such that X belongs to natural numbers, and X is greater than equals to 1 and less than equals to 5. Y is another set such that small y belongs to n, y modulus 2 equals 0, and the last condition is y is greater than 1, greater than equals to 1 and less than equals to 5. So can you tell me what are the elements which set X has? Okay, X has, obviously, since it belongs to n, that means it belongs to the natural number. We know that the natural number starts from 1 and goes till infinity, but the condition is, the bounding condition is, it should be equal to greater than equals to 1 and less than equals to 5. Therefore the numbers are 1, 2, 3, 4 and 5, right? Similarly Y, as you can see that these two conditions are same, so obviously the range of the numbers will be from 1 to 5 and it is a natural number, but the condition is given that y modulus 2 should be equals to 0. That means what? It is an even number. So all the even numbers between these ranges, right, should reside in this set. So 2 and 4, right? Now if I ask you to represent this thing in a Venn diagram, how do you represent? Obviously I think you are able to do it now. X is the superset, right? X, and Y is the subset, Y, right? So I hope you are able to understand Venn diagrams. So now we are going to understand about set operations. Okay, just like in mathematics we have got certain operations like addition, subtraction, multiplication, division, modulus, and there are many more operations. We have got operations in case of sets also. Okay, so the set operations are union. Okay, then we have got something called as intersection. The third operation is called as set difference. Okay, and the fourth operation is called as complement. Okay, so we are going to first understand what do we mean by union. Okay, so union is basically denoted by this symbol. Okay, this is called as the union symbol. Now if I say union, okay, so what do you mean by union? Union means uniting two things, right? So when we say set union, it means that we are trying to unite two sets. Say let us take an example. So I have a set A. It has got three elements, 1, 2 and 3, and I have got a set B. It has got 3, 4 and 5. Fine. So we have got two sets A and B having these two elements, I mean these elements, right? Now if I want to unite these two sets, right, say I want to unite A and B, say A union B, alright, what will be the elements inside this, I mean after uniting, what will be the element in the resultant set? So it will be 1, 2, 3, 4 and 5. Obviously it's a very common thing that you have 1, 2, 3 and 3, 4, 5. So obviously when you are uniting, these 1, 2 and 4, 5 will come, and out of these two threes we are going to write only 1, 3, because a set consists of only unique elements. I have discussed it in the first video of set theory, right? So I can't write 1, 2, 3, 3, 4, 5, because this is wrong. Okay, this thing is wrong. We can't write it in this way. We have to write 1, 2, 3, 4 and 5. Now if I want to represent this thing inside a Venn diagram, right, as a Venn diagram, how do we do it? So we write U here, we have a set A here, and we have a set B, right? Now why I have overlapped it? It is because of this element 3, right? Since 3 is the common element, so there will be an overlapping. So a set A and a set B. A set A will consist of 1, 2 and 3, right? It's a part, the 3 is a part of set A and set B as well. So, and the set B is going to consist of 3, 4 and 5. Now we are going to unite it. Obviously we have to shade the entire two spheres, two circles we have to shade. This denotes union. So basically how do you denote union? Suppose you have this two set 1 and 2, say A and B, right? You basically shade the two circles and you denote in this way, union. So this basically denotes union. Secondly, so I hope you are able to understand union, right? Now secondly, we are going to go for intersection. We are going to understand intersection now. So what do you mean by intersection? So basically intersection will give you the common element, right? Union gives you all the elements including the common element, but intersection is going to give you the common element only. Say A, I write 1, 2 and 3, and B, I write 3, 4 and 5, right? Now if I write A intersection B, now intersection symbol is this, just the opposite of union. So if I write A intersection B, can you please tell me, or can you tell me what the element will be? Since you can see that the common element is 3, right? So 3 will be the answer, right? Now if I draw it inside a Venn diagram, U, A, B, the common element lies here, right? So we are going to just shade this portion. This basically denotes intersection. Okay. Now let us give one more example. Suppose I write it in a set builder form. Say A, X such that X belongs to N, X is greater than equals to 10 and less than equals to 15, and B such that Y belongs to N, Y modulus 2 not equals 0. Okay, let me just clear it so that it's very easily understandable. Okay, so Y modulus 2 not equals 0, and Y basically is okay, so yeah, 15. So can you tell me what are the elements in A? Obviously we know that 10, 11, 12, 13, 14 and 15. what are the elements in B? Since it's an odd number, right? So B will consist of, what? 11, 13 and 15. Now if I tell you A intersection B, what will be the answer? Obviously you can see that what are the common elements? 11, 13 and 15 are the common elements here. So A intersection B will be nothing but 11, 13 and 15, right? And I hope you can like draw it in a Venn diagram. It will be just similar to this, right? Now if I ask you one more example, right? If I give you one more example related to this thing, right? Say, okay, so let's keep A in this way and let's change B, right? Let's change the bounding condition of B. So the bounding condition of B is like y is greater than 2 and less than 5, okay? So less than equals to 5, greater than equals to 2. So what will be B here? B will be your 3 and 5, right? And what will be your this? Obviously 10, 11, 12, 13, 14 and 15. This will be A. Now if I ask you what will be A intersection B? Obviously you can see there is no common element in between, right? Therefore the intersection of A and B will be nothing but 5, an empty set, right? So if I draw it in a Venn diagram, obviously you can see that since there are no intersections or basically since there are no common elements, there will be no overlapping. So A will be this and B will be this. And intersection is obviously going to give you 5. So there you can't denote it in this way in the Venn diagram. So there is no intersection because there is no common element. So there is no overlapping, right? So I hope you are able to understand intersection. Now we are going to understand what do you mean by set difference. Okay. So now we are going to understand about what do you mean by set difference. Okay. Set difference. So difference means subtraction. Okay. So if I say, okay, there are two types of subtraction. Obviously A minus B will be 1 and the second one is B minus A. Now what do you mean by A minus B? Suppose you have a set A, right? Let me just draw it in the help of a Venn diagram. This is the universal thing. You have A, you have B, right? Now if I say A minus B, right? So what you are doing, you are subtracting B from A, right? Subtracting B from A. So if you subtract B from A, what you are removing? You are removing the entire B portion, right? Plus whatever there is common between A and B, you are removing. So what is left? Only the unique portion of A is left, which has no common element with B. For example, if I give you a simple example, right? Say A, right? A has 1, 2, 3, right? And B has 3, 4 and 5. Can you tell me what will be A minus B? Obviously it's going to be 1 and 2 because 3, 4 and 5 will get removed. Similarly 3 is common in A and common in B, therefore 3 is also going to get removed. So 1 and 2 will be nothing but the output or the answer. Now similarly B minus A is nothing but the same concept you will have to apply. So the common elements in A and B will be removed plus all the elements in A. So obviously what we are going to get is 4, 4 and 5. Okay. So I hope you are able to understand set difference also. Now the last topic is complement. Okay. So it is denoted by A complement, where A is nothing but a set. Okay. So suppose I have this and this is A. right? A complement basically denotes all the elements, okay, which is not a part of A but a part of U. So entire universe will consist of A complement apart from A, because we are basically subtracting what? A from U. So it's nothing but U minus A. It's also denoted as U minus A. Suppose I give you an example. Say U has got 1, 2, 3, 4, 5, 6 and 7, and A has got say 2 and 3. Okay. So if I ask you what will be the A complement, obviously 2 and 3 is going to get removed from this U, the rest of the things will remain. So A complement will give you 1, 4, 5, 6 and 7. As simple as that, right? So this is nothing but complement. So with this we are done with set operations. Okay. So I hope you are able to understand what are set operations, the various types of set operations which we use in set theory. Apart from this, you are able to understand, I hope, that what are Venn diagrams and how do we represent sets with the help of Venn diagrams. Now what I'm going to do is, obviously I'm going to write all this stuff down and upload in my Google Drive, the link of which you are going to get in the description section below. And if you have liked my video, this video, and also my previous videos, if you have loved the content, please to like, share and subscribe this channel. It will be a very good moral booster for me, and I'll be coming with more such videos. Till then, stay safe, have a great day, and bye.